Hi dear students, today we are discussing about significant figures in this short video. Significant figures are the digits in a number that carry the meaning contribution to its precision. The general rule for finding number of significant figures, all non-zero digits are significant. So the given number is 237, so which contain 3 significant figures. Same way the second one. Coming to the rules for finding number of significant figures, all the non-zero digits are significant. So for 25, 3 significant figures and 3.81, 3 significant figures. Here, irrespective of the charge, we have to find the significant figures. Zeros between non-zero digits are significant. So the zeros which are there between non-zero digits are significant. So for the given number, 4 significant figures are there. Same way, leading zeros, which will be before the non-zero digit, not considered as significant figures. So 0.33, sorry, 0.0034 have only 2 significant figures. Similarly, trailing zeros in a decimal point, zeros to the right of a decimal point are significant. So 2.50 have 3 significant figures, 73 have 4 significant figures. Similarly, trailing zeros in a whole number, like, so in the whole number, zeros will not considered for finding significant figures. So 1500 means it contain only 2 significant figures. Suppose if it is with a decimal point, as like mentioned, so it's contain 4 significant figures. When decimal point included, so those zeros also comes in the significant figures. So a exact number like counts, definitions, and conversion factors have infinite number of significant figures. Suppose 12 apples, 10 bananas. So those are related to counts. For them, it is having infinite significant figures. And how to do operations and find significant figures. Suppose addition and subtraction, answer should have the same number of decimal places as the least precise measurement. So in the example, 12.11 and 2.13. So in these two numbers, 2.3 is having less decimal points, which is only 1. So after adding, we get 14.41. So that we can write it 14.4 only, because 2.3 have least number of decimal points. So answer also represents with accordingly 14.4, 1 decimal point. Even for multiplication and division, so answer should have same number of significant figures as the least precise measurement. So in the given 6.25 have 3 significant figures, 2.1 have 2 significant figures. So after multiplying, we get 13.125, but we take only 13 because 2.1 is having least significant figures. Accordingly, we have to represent the answer. Suppose if mixed fractions are there, like multiplication, division, then addition or subtraction, we are going to follow BODMAS rule. So accordingly, we can find the number of significant figures. The given examples are there, so you can also check how to find number of significant figures. And finally, rounding rule, which is here. So if the next digit is 0 to 4, keep the last digit itself. You can see the first example here, round 1. So 2.785. So we are writing for 3 significant figure, which is 2.79. So similarly, 2.784. So it has 3 significant figures. So we are indicating for 3 significant figures, which is 2.78, because here 4 is there in the first example.